Hello, folks. Hope you're doing well. Today, I do want to run through a quick lesson with you about how we get our electricity, because having electricity made at a power plant is great and all, but we, of course, we want it for ourselves. And so, how do we get it to our home, and how does that all uh, work, and what does the process look like? So, that's what our focus is on today. Um, Now, we learned a little bit about electromagnetic induction and Faraday's law, and how we can create a current by moving a magnetic field near a conductor, and how a moving magnetic field by a conductor can create voltage. Well, uh, power plants and generators, of course, are going to use that concept. And inside that power plant, that generator that has a turbine that's going to spin at 60 hertz, 60 times a second. Okay, and it turns those magnetic coils to create our electrical current and create our electricity. All right. Now, as that magnet spins, the north and south poles, of course, are going to rotate, and those poles then will switch orientations, which causes the electrical current to also change its direction. It's going to alternate its direction with every half turn. We create what we call an alternating current as those poles switch. Um, from the power plant, then, after we've generated our electricity, we actually send it to a relay station that we're going to, what we say, step up the voltage. We have these things called transformers, and transformers are devices that we use to change the voltage. And we want to step up the voltage, so we have a high voltage going through those power lines that carry the electricity long distances. It actually is a more efficient way of making it happen. We don't want that high voltage to come into our homes, though, so we have what's called a step-down transformer, which reduces the voltage before it comes into your house. Steps it down to about 240 volts. Um, so a couple of terms here, that step-up and step-down transformer. Transformers, like we said, change the voltage of the electricity. Step up, as the name would imply, is going to increase it. Okay, we like to have that again as we send it long distances through the power lines to reduce the amount of electricity we lose due to resistance in the lines themselves. Stepping down the transformer, stepping down the electricity by a step down transformer lowers that voltage, so we don't fry our electrical equipment in our homes. Now, this process only works with what we call alternating current. Okay, if we look at a transformer, it's basically kind of like a iron donut, or you see this in this case a square where you've got loops of wire on both sides. All right, and you've got what we call a primary coil and a secondary coil. This they call primary winding and secondary winding, but the same idea. All right, and what happens is the electricity will come in to the primary coil. As it loops through there, it's going to, of course, create an electromagnetism. But since alternating current changes the direction of the current, it's also going to change its magnetic poles repeatedly. And that moving magnetic field produces a voltage on the other side. It produces a voltage on that secondary coil. Now, depending on if you have more coils in the primary coil versus the secondary coil, that determines if it's a step-up or a step-down transformer. All right, now outside your homes, you'll probably have some sort of bucket up there in the power lines. Ever wonder what that is? That's where the transformer is for your home. Now, the changing direction of the current allows for that magnetic field in the transformer to induce a voltage on the other side. All right, and I can either step it up or step it down depending on what my goal is. Now, this leads us to one of the important historical events in our electrical transmission, and that happens because there was a time when one of our most famous scientists, Thomas Edison, wanted to send electricity through a direct current. Um, but that's not nearly as efficient a method as the methodology that Nikola Tesla put together with the alternating current. And there was a big debate and really a fight for which method would be used because, well, of course, there's a lot of money on the line. So today, what I want you to do, there's a video link here to watch a short little video about Edison and Tesla. Real interesting story. Want you to watch that. Got a quick quiz to do. Have a great weekend, and we'll see you soon.